In the early morning hours of 23rd April 1987, a growing sense of anticipation hung over the skyline of Bridgeport, Connecticut, as workers and residents looked on with muted excitement at the silhouette of a new 16-story residential tower rising above the city, promising modern living and architectural innovation. Before dawn had fully broken, a faint rumble stirred the air, signaling the start of another busy day on the construction site, where hopes and expectations were firmly set upon a building deemed to redefine high-rise home building in the United States. Viewer discretion is advised, for in the calm that precedes disaster lies a chilling reminder of human ambition and engineering fallibility. Bridgeport in the mid-1980s was a city in transition, seeking renewal after decades of industrial decline. Developers and city officials alike championed bold projects as symbols of economic revival. It was within this atmosphere of optimism that the Plaza project took shape. Conceived as a beacon of urban renaissance, the tower would utilize the innovative lift-slab construction method, a technique promising to speed up building times and reduce labor costs by casting floor slabs horizontally at ground level before lifting them incrementally into place. The Lift-Slab method had surged in popularity during the preceding decade, admired for its elegance and efficiency, yet it carried inherent risks that critics cautioned against. Engineers emphasized that flawless synchronization and rigorous safety checks were vital to prevent structural misalignment or catastrophic failure. Nonetheless, the buzz around Plaza overshadowed such concerns as project managers raced to meet ambitious deadlines, driven by financial incentives and public expectation. On the day of the collapse, the sky was awash of pale blue and soft clouds, the air carrying a gentle breeze from the nearby Long Island Sound. Below the skeletal framework of steel girders and concrete slabs, construction workers in hard hats and neon vests moved about with practiced urgency. Cranes towered overhead, their booms swinging slabs into position with precision that had become almost routine. Each lifted floor seemed to glide into place, as if by magic, leaving onlookers in awe of the enormous panels hovering above the street. By mid-morning, the 13th slab, each weighing several tons and spanning the length and width of the tower footprint, had been successfully hoisted to its designated height. Engineers and supervisors conferred at ground level while welding torches sparked in the distance. Moments later, as another slab began its ascent, an unsettling creak resonated through the steel framework. Some workers paused to listen, exchanging concerned glances, while others carried on unaware. Then, in an instant that defied belief, the creaking gave way to a deafening roar. The temporary supports and cables designed to secure the newly lifted slabs failed one after another in rapid succession. Concrete panels fractured under their own weight, metal beams buckled with a sickening twist, and the structure collapsed in a pulverized torrent of dust, debris, and twisted rebar. The world seemed to stand still for a heartbeat before chaos erupted. From a distance, the collapse resembled a giant accordion collapsing inward, sections folding onto themselves in a horrifying display of mechanical failure. Clouds of chalky dust engulfed the site as steel and concrete rained down upon the workers below. Screams and shouts pierced the air as men scrambled for cover while the ground shook with the force of falling slabs. Emergency sirens began to wail as stunned witnesses dialed for help and rescue crews rushed toward the smoldering wreckage. In that split second, the promise of architectural triumph turned into a scene of unspeakable tragedy. The very method that had been hailed as the future of construction revealing its darkest flaw under the weight of optimism unchecked. The stage was set for a story of heroism and heartbreak, an investigation into how human ingenuity could so swiftly falter, and a sobering lesson that even the most celebrated advances demand the utmost respect for safety and caution. In the days leading up to the fateful morning, engineers had taken pride in the elegance of the lift-to-slab technique, a method whereby massive concrete floors were poured and cured at ground level and then raised one by one on hydraulic jacks, like pages of a giant book closing skyward. Each slab was meticulously positioned atop steel guideposts, its weight carefully balanced, while teams of welders and inspectors monitored every joint and bolt for signs of stress or misalignment. Despite the complexity of the operation, confidence ran high as project managers boasted that Plaza would be completed ahead of schedule, a testament to human ingenuity and modern construction practices. Yet beneath the veneer of efficiency lay latent vulnerabilities. The hydraulic jacking system depended on uniform pressure across multiple points, any discrepancy threatening to tilt a slab imperceptibly and overload adjacent supports. Temporary locking collars had been designed to secure each floor in place until permanent connections could be welded, but whispers among seasoned foremen hinted that not all collars were seated properly, that some had slipped slightly during earlier lifts. Weather forecasts had predicted light winds and clear skies, and on the morning of 23rd April, the air remained calm, but hidden forces were already at work in steel and concrete. Inside the site, office blueprints and checklists were passed back and forth as supervisors conducted final walkthroughs, visually confirming that anchor bolts protruded at the correct height and that hydraulic hoses were free of kinks or fluid leaks. The 22 slab lifts preceding the 13th had proceeded without incident, lulling many into a false sense of security. To the untrained eye, each level appeared perfectly aligned, seams between panels tight and seamless, but microscopic fractures had begun to form around bolt holes where stress concentrated. These hairline cracks were invisible to casual inspection and only detectable via ultrasonic testing, a procedure that had been scheduled for later in the week but postponed in favor of expediency. By mid-morning, the hum of machinery drowned out ambient noise as a new team prepared the 13th slab for hoisting. Inside the concrete's interior, a lattice of reinforcing bars, known as rebar, worked under enormous strain as hydraulic pressure was applied to lift the slab. Welders stood by, their torches aglow, ready to secure the perimeter plates once the slab reached its destination, while ground-level spotters communicated via radio headsets, their voices clipped and efficient. Tension gauges registered readings that hovered near safety thresholds, but supervisors were reassured that a small margin of error remained and that any slight deviation would not compromise overall stability. Moments before the collapse, a senior engineer radioed to confirm that all four corners of the slab had engaged their lock collars, the rust-red collars visible only to those expecting to see them. The response crackled back that the locks were in place, and attention turned to guiding the slab into its final position atop the 12th level. A gentle nudge from a crane operator nudged the slab forward, and for a fleeting second the structure held, suspended like a giant platform above the city, before an ominous sound echoed through the site, faint at first but growing in intensity. Metal shrieked against metal, a warning born of torsion and fatigue, and the hydraulic pressure gauge leapt beyond its normal operating range. Alarm bells rang out as workers looked up, eyes widening in disbelief at the sight of the 13 slab dipping unevenly, one corner sagging by several inches. Voices on the radios turned frantic, urgent commands to halt all lifts and initiate emergency protocols, but disbelief and momentum conspired against them. Gravity seized the momentary weakness, and the slab dropped with impossibly swift motion, its downward acceleration dragging adjacent floors into a cascading failure. The temporary supports buckled one after another like dominoes, and within seconds the entire midsection of the tower gave way in a tumultuous collapse. As the dust cloud billowed skyward and debris rained down upon the street below, the promise of modern construction lay shattered among the ruins. In the silence that followed the roar, the full weight of the disaster began to sink in for those who had witnessed it, the realization that human ambition, untempered by patience and caution, had unleashed forces beyond control, and that even the most celebrated engineering feats can falter when warnings go unheeded. In the immediate aftermath of the catastrophic collapse, rescue efforts unfolded amid a haze of dust and the acrid scent of crushed concrete. Emergency crews, firefighters, paramedics, and police rushed to cordon off the scene at the corner of Iranistan and South Avenue, where mangled steel and shattered slabs lay heaped like fallen giants. Within minutes, stretcher bearers and first responders waded into the wreckage, guided by frantic shouts and the groans of trapped workers. Above them, cranes stood immobilized, their booms twisted and dangling, stark reminders of the mechanism that had so quickly turned from marvel to menace. At Ground Zero, medical teams established a triage station under a makeshift canopy of tarpaulins, while ambulances queued along the perimeter. Severely injured men, their faces smeared with dust and blood, were loaded onto gurneys, some conscious and clutching hands in prayer, others unconscious, their breathing shallow and ragged. Overhead, the muffled roar of jackhammers signaled the onset of search operations, as urban search of rescue specialists probed through debris, calling out names and listening for any sign of life. In one corner, a firefighter pried open a cavity between slabs to extract a young laborer who, against all odds, had clung to a void in the concrete long enough to survive until help arrived. Meanwhile, local hospitals braced for a flood of casualties. Emergency wards lit up like beacons in the dawn as doctors and nurses prepared blood transfusions, set broken limbs, and attended to severe crush injuries. Some victims required immediate amputations to free them from twisted rebar and collapsed support beams, while others were treated for smoke, inhalation, and shock. The sudden surge overwhelmed staff, but doctors worked feverishly, pooling resources and soliciting donations of blood and medical supplies from nearby communities. As daylight broke fully, the mayor of Bridgeport declared a state of emergency, urging calm while promising a full investigation. On the steps of City Hall, he addressed reporters. "Our thoughts and prayers are with the injured and the families of the fallen. We will spare no effort to uncover the cause of this tragedy and to bring support to those affected." His words, though solemn, rang hollow to those still searching for missing friends and colleagues among the rubble. Family members had gathered at the perimeter, clutching photographs and personal effects, desperate for news. Some wept openly, others stood in stunned silence, gazing at the chaotic removal of debris, as if hoping the collapsed tower might somehow reassemble itself. A local pastor offered prayers and words of comfort, while volunteers passed out water, blankets, and sandwiches to keep vigil through the long hours. Rumors swirled. Some said it had been sabotage. Others blamed shoddy workmanship. But amidst the confusion, one fact remained unassailable. Dozens of lives hung in the balance. By midday, heavy machinery arrived, cranes with extended reach, hydraulic cutters, and concrete pulverizers to begin the painstaking process of lifting slabs one by one. Structural engineers on site cautioned that any misstep could endanger both survivors and rescuers. They marked unstable sections with neon tape and calculated low G-bearing capacities in real time, advising operators on which anchors and supports to shore up before proceeding. Under this orchestration, debris was methodically removed, revealing cavities where trapped men might yet be found. But as the hours dragged on, cold reality set in. Many pockets had become death traps, sealed off by collapsed concrete and constrained by the very method intended to protect them. By the second day, 10 bodies had been recovered, each one greeted with solemn ceremony before being transported to the city morgue. A hush fell over the site whenever a covered stretcher emerged, accompanied by the mournful notes of a bagpipe played by a member of the local fire department honor guard. Investigators from the Occupational Safety and Health Administration and the State Building Department arrived to document conditions and secure evidence. They photographed fractured bolts, measured misalignments, and collected samples of hydraulic fluid and concrete cores, all while construction managers watched anxiously from behind yellow tape. In the nearby community center, a hotline was established for families seeking information. Counselors offered grief, support, and legal advice, warning relatives of potential liabilities and guiding them through compensation procedures. Local news helicopters circled overhead, broadcasting live images of the ravaged site to viewers across the region, while national media began to ask deeper questions. Had safety protocols been compromised? Were financial pressures to blame? And above all, how could a building engineered to rise effortlessly fall so spectacularly? As the sun set on the second day, rescue teams exhausted but resolute prepared to continue their search at first light. The skeletal frame of L'Ambiance Plaza, once a beacon of progress, now stood as a stark monument to tragedy and a pivotal chapter in modern construction history. The story was only beginning, and with each slab lifted, new clues would emerge to explain how the ambitions of man collided so violently with the forces of nature and physics, leaving a city in mourning and an industry forever changed. As the dust settled and the last of the slabs were removed, attention turned from rescue to reckoning, for the collapse of L'Ambiance Plaza demanded answers and accountability. Within 24 hours of the disaster, the governor convened a special commission composed of structural engineers, safety experts, and legal authorities, charged with conducting a thorough inquiry into every facet of the project. Their mandate was unambiguous: to identify the root causes of the failure, to assign responsibility where negligence or error had occurred, and to recommend reforms to prevent such a tragedy from repeating itself. Inspectors began by examining the crane and jacking equipment, tracing hydraulic lines from manifold to cylinder, and inspecting pressure gauges and safety valves for signs of malfunction or tampering. They cataloged every fallen slab, measuring the locations of fractured rebar, noting patterns of concrete spalling, and testing core samples for compressive strength. Blueprints and construction logs were subpoenaed to trace the sequence of slab lifts, and weld records reviewed to confirm that each lock and collar had been properly seated and torqued to specifications. Interviews with site personnel revealed a sobering pattern: that pressure to expedite the schedule had overridden caution, that promised ultrasonic tests had been deferred, and that several temporary supports had been removed prematurely to make way for finishing work. Foreman admitted that minor misalignments had been observed during earlier lifts, but that supervisors dismissed these as acceptable tolerances. Hydraulic maintenance logs contained entries noting fluctuating pressures on the day of the collapse, yet these anomalies were never reported to higher management, presumed inconsequential in the face of looming deadlines and growing costs. The Commission's preliminary findings, released 6 weeks after the incident, cited multiple failures in design oversight, quality control, and project management. They concluded that the immediate cause of the collapse was the catastrophic failure of the 13th slab's temporary locking collars, which had slipped under uneven hydraulic pressure, initiating a chain reaction that overloaded adjacent supports. Contributing factors included inadequate safety margins in the lift-to-slab design, insufficient inspection of critical welds, and a work culture that prioritized speed over strict adherence to established protocols. In its final report, the Commission issued a series of recommendations, calling for mandatory third-party review of heavy lift procedures, stricter enforcement of non-destructive testing at every stage of slab placement, and comprehensive training programs for crane and jack operators. It proposed revisions to building codes to require redundant backup systems for critical supports and to limit the permissible load on temporary collars. The Occupational Safety and Health Administration levied substantial fines against the general contractor and the equipment manufacturer, citing willful disregard for safety regulations. Yet even as the official narrative took shape, questions lingered and alternative theories emerged. Some industry insiders speculated that a design flaw in the hydraulic manifold, undetected during prototype trials, had caused a sudden loss of lifting pressure, triggering the collapse without any human error. Others pointed to possible sabotage, noting that one night before, the collapsed unauthorized personnel had been seen near the staging area, though no evidence of tampering was ever produced. Conspiracy theories circulated that cheap imported bolts had been used in place of specified grade 100 bolts, a cost-cutting measure concealed in off-Y books accounting. Local journalists pursued these angles with fervor, interviewing whistleblowers and poring over financial records that hinted at cost overruns and secret change orders. Advocacy groups for construction workers demanded criminal charges against responsible executives, while families of the victims filed wrongful death lawsuits alleging gross negligence. The courts would later award multi-million-dollar settlements to dozens of plaintiffs, though no executive ever served jail time, and the general contractor declared bankruptcy in the wake of mounting liabilities. Through it all, Bridgeport wrestled with the memory of the disaster, erecting a modest memorial plaza near the site, inscribed with the names of the 28 workers who perished. Annual commemorations brought together survivors, families, and colleagues who read aloud stories of heroism, of men who shielded others with their own bodies, of those who stayed behind to guide rescuers to trapped teammates. Their voices echoed the dual lesson of the tragedy: that human courage can shine brightest amid ruin, and that progress demands not only ingenuity, but unwavering vigilance toward safety. Thus, the story of L'Ambiance Plaza became more than a cautionary tale of engineering hubris. It became a testament to the delicate balance between ambition and caution, and a reminder that every bolt and beam carries the weight of human lives when the skyline grows upward. In the years following the tragic collapse of L'Ambiance Plaza, the construction industry grappled with profound reflection and reform as the echoes of that April morning reverberated through boardrooms, legislative chambers, and training facilities, reminding every architect, engineer, and laborer that the pursuit of innovation must never outpace the imperative of safety. Lift-Slab projects worldwide were scrutinized under new regulations. Non-destructive testing became a mandated standard at every critical juncture, and hydraulic systems were redesigned with redundant controls to prevent uneven pressure from compromising structural integrity. Universities incorporated the lessons of Bridgeport into their engineering curricula, dedicating case studies to the failure analysis of Slab 13 and equipping the next generation of professionals with the tools to recognize the subtle signs of structural distress. Building codes were amended to require third-party certification not only of final designs, but of interim conditions throughout the assembly process, enforcing a culture that valued caution and verification above speed and cost savings. Meanwhile, professional societies published best practice guidelines for lift-to-slab construction, emphasizing continuous monitoring, real-time data logging, and rigorous documentation of every weld, bolt, and hydraulic adjustment. On the 15th anniversary of the disaster memorial services drew survivors, families, and industry leaders back to Bridgeport, where a new commemorative center opened its doors adjacent to the reconstructed site. Inside, a permanent exhibit showcased photographs and artifacts from the collapse, including fragments of rebar twisted into irreparable angles and sections of concrete marked with bolt hole fractures. Interactive displays allow visitors to simulate slab lifts under varying hydraulic pressures, highlighting how even slight imbalances could trigger catastrophic failure. Oral histories played in a dimly lit gallery recounting the voices of those who perished and of rescuers who risked their lives in clouds of dust to pull colleagues from the wreckage. Despite the industry's concerted efforts to learn from the disaster variants of the lift-slab method persisted in niche applications, though always tempered by enhanced safeguards and oversight. Advanced sensor networks now monitor stress and strain in real time, transmitting alerts to site managers and offsite engineers. Crane operators undergo specialized certification and psychological evaluation to ensure they can respond calmly to anomalies, while project schedules include mandatory buffer periods specifically allocated for safety, audits, and maintenance. Insurance underwriters apply rigorous risk assessments to lift-slab proposals, often requiring third-party engineering audits before coverage is granted. Yet the memory of L'Ambiance Plaza continues to serve as a solemn warning that progress without prudence can yield outcomes as devastating as any natural disaster. In Bridgeport community, leaders championed the creation of a scholarship fund in the victims' names to support students pursuing careers in civil engineering and construction safety, ensuring that future innovators remain ever mindful of the human stakes embedded in every blueprint and building site. Annual symposiums draw experts from around the globe to discuss emerging technologies and to debate how best to balance efficiency with the unpredictability of materials, weather, and the limits of human oversight. For the families who lost fathers, brothers, and sons that April morning, no amount of regulation or memorialization can fully erase the pain of lives cut short. Yet, in their grief, they found purpose, joining advocacy groups that lobby for stricter enforcement of safety laws and greater transparency in construction contracts. Some have shared their stories in documentary films and podcasts, urging policymakers and practitioners alike to never forget the faces behind the data points and to recognize that each piece of steel and concrete bears the weight of human hope and vulnerability. As modern skylines continue to rise ever higher, the legacy of L'Ambiance Plaza endures in every concrete pour and slab lift, a testament to the dual nature of engineering achievement and the sobering truth that the margin for error can be vanishingly small. The story of that fateful day remains etched into the collective consciousness of an industry forever changed, a narrative told not only to memorialize those who perished, but to reaffirm a fundamental principle that built into the heart of every structure must be an unwavering commitment to the safety and dignity of the people it is meant to serve. And so this story concludes not with the finality of a collapsed tower, but with the ongoing pledge of an entire profession to honor the lessons of the past, even as it builds the promise of tomorrow, mindful that true progress is measured not only by what we create, but by how carefully we safeguard the lives entrusted to our designs. In the months that followed the collapse of L'Ambiance Plaza, Bridgeport became both a cautionary tale and a catalyst for change. As investigators pieced together the sequence of events, families of the victims pressed for transparency, demanding access to every scrap of data, hydraulic pressure logs, weld inspection reports, even the personal notes of junior engineers. Community meetings were convened in local schools and churches, where victims' relatives confronted contractors and city officials, their voices alternating between grief and righteous indignation. These gatherings, sometimes tense and emotional, transformed into forums for collective healing and public accountability, ensuring that the tragedy would not be forgotten or whitewashed by bureaucratic inertia. Meanwhile, the construction industry at large watched closely. Trade publications ran feature articles on Bridgeport, dissecting the Lift-Slab method step by step and highlighting the points of failure. Technical conferences, once dominated by presentations on cost-saving innovations and ever-faster build schedules, now devoted entire sessions to risk management and safety culture. Speakers recounted the L'Ambiance disaster in measured tones, underscoring that no project, no matter how minor, was immune to the catastrophic potential of a single overlooked detail. Graduate students wrote theses on progressive collapse, and professors updated their lectures to include real-world examples of collapse mechanisms, ensuring that future engineers would learn not just from theory but from the hard-won lessons buried beneath tons of broken concrete. On the regulatory front, legislators drafted new statutes granting OSHA broader authority to inspect work sites using heavy lift technologies. State building codes were amended to require that any project employing lift-to-slab or similar methods submit a detailed safety analysis, complete with third-party peer review, before receiving permits. Insurance companies, having suffered significant claims, introduced premium surcharges for projects deemed high risk and often required specialized safety audits as a condition of coverage. In tandem, accreditation bodies for construction professionals introduced more rigorous licensure exams, incorporating not only technical competency questions, but also scenarios testing ethical decision-making under pressure. Within Bridgeport itself, the rebuilt site of L'Ambiance Plaza took on new meaning. Rather than erect another high-rise, the city commissioned a low-rise mixed-use complex designed with full public input, integrating green spaces and pedestrian walkways. A plaque in the central plaza commemorated the fallen workers by name and included a brief chronology of events, serving both as memorial and as an educational installation. Adjacent to this plaza, a community-run safety training center offered workshops on everything from scaffold assembly to emergency response, available free of charge to local laborers and small contractors. Many of the instructors were survivors or family members of victims, turning their personal loss into a source of collective empowerment. Personal stories continued to emerge over the years, each adding a layer of humanity to the technical narrative. One of the survivors, a welder named Carlos, recounted how he had ducked behind a vertical support post at the exact moment when the slabs above him had collapsed, leaving him with minor bruises but the lingering guilt of friends lost beside him. He returned to the site years later as an instructor, demonstrating correct welding techniques and emphasizing the importance of speaking up whenever something felt wrong. Another story came from Lisa, whose father had been one of the first victims identified. She founded a scholarship in his honor, awarding grants to students pursuing studies in structural engineering and occupational safety. Each year, recipients visited Bridgeport for a memorial service, reflecting on the responsibilities their chosen profession would place on them. Technological advancements accelerated in the wake of the disaster. New hydraulic jacking systems incorporated multiple redundant sensors that constantly cross-checked pressure readings and automatically halted operations if any discrepancy exceeded a fraction of a percent. Wireless strain gauges were embedded within concrete slabs at manufacture, transmitting data in real time to on-site consoles and remote monitoring centers. Even small contractors adopted smartphone apps capable of scanning QR codes on equipment to retrieve maintenance, history, and certification status instantly. These innovations, once the domain of higher budget projects, became standard tools in builders' toolkits, democratizing access to advanced safety monitoring. Internationally, the L'Ambiance Plaza incident was cited in safety guidelines by engineering societies in Canada, Australia, and the United Kingdom. Collaborative research projects examined the comparative performance of different heavy lift methods under extreme conditions, integrating lessons from naval architecture and aerospace manufacturing. Joint firefighting and rescue exercises simulated scenarios in which collapsed slabs and confined spaces required coordinated efforts between urban search and rescue teams and specialized heavy equipment operators. These drills fostered a spirit of shared learning that transcended national boundaries, united by the recognition that human life depends on collective vigilance and cooperation. Yet, for all the reforms and innovations, the emotional scars in Bridgeport endured. On each anniversary of April 23rd, survivors, families, and officials gathered once more at the Memorial Plaza. At sunrise, they lit candles and shared silent moments of remembrance, followed by readings from the last letters and personal diaries recovered from the wreckage. Then, in a symbolic gesture of hope, they released white balloons into the sky, watching as they drifted above the familiar silhouette of the city now transformed, yes, but forever linked to the memory of 28 lives lost. Through these ceremonies and the ongoing work of the Safety Center, Bridgeport reaffirmed that the legacy of L'Ambiance Plaza lies not only in regulations and technological fixes, but in the human determination to learn, adapt, and honor those who paid the ultimate price. In every cleat welded, every bolt torqued, and every slab lifted, the spirit of vigilance lives on, a testament to an industry galvanized by tragedy to build not only taller but wiser and more humane structures for generations yet to come.